that we will have a very interesting discussion on the topic how our smart energy systems can deal with all the renewables which we want to have, and we want to go towards 100% renewables. So a cordial welcome. I myself, I'm now serving as chairman of the European Solar Manufacturing Council. You might know me from my previous time as director of Fraunhofer ISE in Freiburg. And I would like to pass on to Michael, maybe, to continue.
Okay, hi, I'm Michael Schmeler. I'm your moderator today, and I'm happy actually to have this 90 minutes to discuss the smart energy system of the future. I'm for over 20 years in solar. I was one of the founders of Photon magazine, and currently I'm working among several roles as the executive advisor of Solar Power Europe, the association of the European solar sector.
You should say who should continue, Michael.
Oh, okay, that's my, okay, then I see the next on my photo line is Greg.
Hi. Hi, I'm Grégory Lamotte from Comwatt. I'm a CEO. I'm calling you from France, Montpellier, in the south. I am founder and the CEO of Comwatt. It's a startup specialized on IoT, object of Internet of Object, to manage the load, to synchronize production and consumption of energy. And we have got 20,000 customers in France already. And the target of Comwatt is to make the energy cheaper for everybody.
Okay. Thanks, Greg. So then we move ahead from France to Turkey. Digger.
This is Değer Saygın. I'm the director of Shura Energy Transition Center, which is the first and only think tank in Turkey working on energy transition issues. So thanks once more to the organizers for the kind invitation.
Wonderful. Okay, then we do a short flight from Turkey to the West Coast. Angelina.
Hi, everyone. I'm Angelina Galitova, and I'm the founder of Renewables 100 Policy Institute, which was an institute dedicated to the transition of 100% renewable energy in all sectors, specifically the electricity sector being the foundation of the transportation sector, the building sector, and the fuel sector. I'm also the vice chair of the California Independent System Operator, which is one of the largest grid operators in the United States. We currently are launching an energy imbalance market and a day-ahead market for energy. California has committed to 100% renewable energy and transitioning to a carbon-free economy. We now, as the California Independent System Operator, thanks to the EIM market and the day-ahead market, are operating in about 80% of the Western states. So we represent 80% of the Western market and hope that the initiative that California has started, which is now being picked up by Colorado and by New Mexico and by the states of Washington, will transition the West and accelerate to 100% renewable energy, because that's where we need to be. So very happy to be here.
Wonderful. Okay, let's stay in California. Mark.
Hi, I'm Mark Jacobson. I'm a professor of civil and environmental engineering at Stanford University and direct the atmosphere energy program, and have been developing plans to transition to 100% clean renewable energy since 2009, and have been working on climate, air pollution, and solutions to those problems since about 1990. And so, yeah, but lately, most of the work has been on kind of developing and honing these clean renewable energy plans for the world and individual countries.
Okay, wonderful. Okay, back to Europe. Christian, Finland.
Yeah, my name is Christian Breyer. I work as professor for what is called solar economy at Lund University in Finland. What we do in my team is to find out energy transition studies or scenarios for fully sustainable energy systems, which in the end are renewable. But of course, also in renewable energy systems, we find sustainability limits. We have to be careful. For example, biomass, hydropower, there are more limits. For other technologies, with also area limits or others. And that we do in a global local resolution. So we have a global model with 145 regions, but we do also then more detailed country studies or regional studies. And the key question is, what is the value when we go to a fully renewable energy system, and in particular also benchmarked to a conventional energy system as of today, or current policy scenarios. And we increasingly get the solution that the current policy scenarios are really high cost compared to a fully renewable solution.
Okay, wonderful. So what I would like to do now, I give a short introduction to a study actually, which we at Solar Power Europe did. And actually the model came from Christian Breyer and his team. I would like to introduce that before Degar then gives some details on the Turkish energy market, and then we start a discussion. So I have 15 slides, but I will just show the key messages because that probably can serve as a base for the discussion. So Thomas, if you give me the mouse, I try to share my.
It's done. It's done. It's done.
Screen.
You just
okay.
Just click on the green.
And desktop 1 or desktop 2, I don't see.
You are there is a share screen on the bottom.
Yeah,
the green.
That's what I clicked on, and then I see desktop 1, desktop 2, but I don't see pictures. Let's see if that works. Oops, allow, yes, I do. Wait, I have Apple, I have to allow.
So maybe you have presentation.
Zoom will not be able to record the content until it is quit. Oh. Sorry. Apple says I have to quit now and restart the system in order to show the presentation.
But if you wish, Michael, you can send me quickly by email. Okay.
Yes, I'll do that.
See, there is always solution, so no problem.
Sorry. We're fully on GoTo, unfortunately.
There's always a plan B.
Yes.
And then and in the most cases we realize plan C.
Wait, Thomas, here you.
We can even send it through WeChat, no problem.
Yeah, okay, but not on my. Get it?
On WeChat?
Otherwise, we can also have Degar start. That would be also fine.
Did you send on email or to?
Yes, via email.
To Tomasz at.
But Degar, why don't you start? Actually, I think that's also fine. Huh?
Sure, of course.
Yeah.
In that case, I'll be sharing my screen if the host allows me.
Yes, yes.
Okay. Great. Okay. I suppose everyone is seeing that. And I'll try to keep. Yeah.
I have the speakers on top of the screen, so I'm going to try and minimize it.
Okay, great. So I assume everyone is following the screen, and I'll, of course, be focusing on Turkey, which is one of the G20 countries and one of the OECD countries with a rapidly evolving energy system in terms of growth. And that also implies growth in GHG emissions given the large reliance on fossil fuels. But that does not mean that Turkey has been following the global paradigm of energy transition. And I'll try to give a brief overview of what's happening here and what the near future looks like. If you look at the Turkish energy market, we're talking about, since the liberalization of the market in early 2000s, a total investment in cumulative terms of $120 billion. So that's what the Turkish power market, including energy efficiency, has received in the past 17 years. The important highlight here is that around half of this $120 billion investment have gone into energy transition as we define the renewables for power generation, efficiency, and the infrastructure in terms of transmission and distribution to manage that. So this compares with the global numbers. If you look into that value of 1.8 trillion globally, the energy market is receiving investments, and half of that energy transition. We have a similar path in Turkey for that also. The top policy priority of Turkey, of course, every country has a different starting point, but in Turkey, in our case, it's the current account deficit, which is accounted by large share of energy imports, and therefore local renewables. And when I say local renewables, both utility scale and distributed generation, which is what's been receiving the most attention in Turkey, especially solar PV rooftop systems. So that's the first pillar. The other pillar is energy efficiency. In line with other countries, there's quite a thorough and a comprehensive efficiency action plan to 2023, as well as a commitment to reach 1 million EVs and 1 million charging points by 2030. So that's a cross-cutting technology, of course. And what's interesting here is also there is a big interest on the local lignite, as it's a local resource, domestic resource, as means to current account deficit reduction. And that said, the lignite quality in Turkey also suffers from not being the highest heating value, so that has some inefficiency issues. But these are the three pillars of what Turkey is looking into. When we focus on the power sector, we talk about the size of 90 gigawatts, more than 90 gigawatts with around 300 terawatt hours per year generation. And last year, with a good season with rains, more than 40% of all generation came from renewables. When we look into the variable renewables, that was only 10%. So that's the level we're talking about in terms of variable renewable energy penetration. A recent study by Shura showed that from 10%, you could go up to 30% variable renewables by 2026. And to accommodate that or integrate that into the transmission grid, a number of solutions would be needed, including battery storage, pump hydro, more flexible power plants, demand response, and placing solar and wind closer to demand centers. And we've studied what the costs and benefits of flexibility options in Turkey would be. We addressed a range of battery storage technologies as well as mechanical storage. The right-hand side shows the costs of that red line. So much of the technologies as it stands currently are somewhat more expensive, or there are more costs compared to the benefits for flexibility. But overall, compared to the short-run system cost or the spot price of electricity, integrating 30% solar and wind in Turkey requires an additional 1 to 5% increase in average system costs. When we look at the rooftop solar PV potential, Turkey has around 9 million buildings. And in those 9 million buildings, majority of that are residential buildings, but a significant potential for solar PV at grid parity or even lower than the electricity tariff exists in non-residential buildings, mainly in commercial and industrial, shopping malls, etc., of around 5 gigawatts. So that's a readily available potential which can contribute to this energy transition as it stands. And we have a monthly net metering scheme in place and some business models being discussed on top of that to make that potential happen. Of renewable energy regulatory framework is supporting this. I won't go into details of this, but auctions are becoming more and more common policy in Turkey. The recent auctions on onshore wind as well as solar PV were quite favorable and lower than the global average. You see that on the bottom. Last summer, we had 1 gigawatt auction across 4 areas with winning bids between $3 and $4 cents per kilowatt hour. And the government commitment is to continue with these auctions in the coming decade. Let me spend a few minutes on the EV, which is one other pillar of the energy transition in Turkey. As of now, we start from a low base of EV, but the potential we've shown in a Shura study based on real distribution grid data is 2.5 million EVs can be integrated in the vehicle stock. That would represent 10% of the total passenger vehicle stock by 2030, meaning 1 out of 2 vehicles would need to be sold EVs. and that would require around 1 million charging points at different home, work, and public place locations. And the investment need of that EV integration is 1 to 10% of the distribution grid planned investments to 2030. So that's, I would say, a reasonable level for integrating EV. And finally, one word on the energy efficiency. As I mentioned, we have quite a detailed and thorough efficiency action plan to increase the 1.5% energy intensity rate improvements since the past 2 decades. It's quite a thorough plan, also an ambitious one, cross-cutting across all sectors. And this would be the, I would say, the last pillar which I want to mention from the Turkey energy transition perspective. So thanks so much for your attention, and any questions, and later I'm happy to contribute to the discussion as well. Thank you.
Thank you.
Thanks, Digger. Okay, Thomas, you take
yes,
over.
received. Yes. Let me just not mix the screens. This one. Okay. Sure. Can you see?
Yeah, perfect.
Yes.
Okay, wonderful. Okay, what I want to do is actually, I want to show you the latest results of our study, which we did together with LUT, with Christian Breyer's team. We published it last week, and it was about 100% renewable Europe, how to make Europe's energy system climate neutral before 2050. So why did we do that? There's a lot of such reports, but I think none of them is really 100% renewable in Europe, and none of them looked at the latest numbers, cost numbers for solar. So next slide, Thomas, please.
Yes.
Okay, so we did 3 scenarios basically, and one is a laggard scenario, which doesn't meet the European Commission's carbon climate neutrality target by 2050, as the renewable share will be still 62%. Also, fossil fuels are not phased out, nuclear also not, and we have a moderate and a leadership scenario, and here in a nutshell, the difference is that the leadership strives to be 100% renewable by 2040, the moderate only in 2050. In consequence, the leadership results that more ambitious Paris targets are achieved, while the moderate results that the 2 degrees target is achieved, but not the 1.5. Next slide, please. If you go on view, Thomas, actually, then you can click. Okay, yeah. So here we benchmark what has been done for Europe. So I think none of the reports that has been published so far was as ambitious as ours. So no other study has explored 100% renewables without carbon sinks. So most the others that were there, Primes, for example, they used this little tricks. We didn't do that. And no other report modeled 100% scenario already for 2040. Next slide. Key message, everything is about electrification. Here we look at primary energy demand. Today, electrification rate is 1 digit. If you look to the right side and look at the green parts of the bar, you always see the 3 different scenarios next to each other. You see that for the 100% renewable scenario, we have electrification rates of 85 and 86%. So key message is simply high electrification rates are key for a 100% renewable system. Next slide. Okay, I think that's new, probably not so much for the world, but for Europe. So that means 100% renewable energy world in Europe on the continent means actually that this is primarily a solar story. If you look at these slides, you simply see that in 2050, both 100% renewable scenarios, the moderate and the leadership, have around over 60% of power being produced by solar. If you look at look at capacities, actually this share is even higher, simply because wind has a better capacity factors. So here, the capacity-wise, the share would be at over 70%. I think the key takeaway, and I think this is what we should also discuss later on, is simply the sheer dimension we're talking about here. So in the different 100% renewable scenarios for Europe, we see that we need 7.7 or 8.8 terawatt of solar being installed. Today we're at around Europe-wise 150 gigawatt or so. So that means the dimensions that we're looking at, and we have, depending on what the target is, either 20 or 30 years left. Next slide, please. Get there. So that was electrification. I wanted to briefly look into the different other sectors. So, Thomas? Thomas?
I'm here just trying. The screen is
Next slide, yeah.
the problem is
Okay. Then we go from electricity to heat. Electricity is pretty much advanced in Europe. So, so in terms of renewables, heat generation is lagging behind quite a bit. But here the key message is actually, again, heat pumps will simply be the core part of a 100% renewable energy system. So over 60% share of heat generation will come from heat pumps. We have also other shares, but I think let's keep that as a key takeaway and then move further to transport. Transport, like probably everywhere else in the world, is lagging most behind. So we have around 5% of renewables being used for the transport sector. If you look at the energy needs, again, so what you see here is that electricity, of course, also has its effect, electrification, but in transport it's different because electrification is mostly, or direct electrification, we see mostly for EVs, but the much bigger energy needs are obviously coming from aviation and marine. And here it's synthetic fuels, which where we require really significant volumes for. And so the next message is actually that on the one hand, it's high electrification, and second, we need obviously hydrogen as the platform to go to synthetic fuels. It's a second important energy carrier. Another message is, if we look at storage output, batteries provide the bulk of energy storage in a 100% renewable system, different applications. But in any case, it's simply the cheapest form, and they will be key, obviously mostly for power, but nevertheless, if you look at it as a whole, it's mostly batteries. Next slide, please. Still, if you look at total energy demand, the storage output that's needed for all of the scenarios in 2050 is at max 25%. Why that? Sector coupling and high electrification rates simply are more efficient, and that's why they keep the storage needs at that level. Next slide. So we looked at it also on a regional scale. That's pretty obvious, the results. In the southern part of Europe, you have more sun. In the northern part, you have more wind. But if you look at both together, you always have, or you have an average over 90%. I think most of the scenarios is almost 95% coming from these two suppliers. Of course, and that's what we also would want to discuss, and we looked at that. We have an hourly resolution, so we zoomed in. Basically here we did that for France for a week in spring and 1 week in winter, because people always fear that the lights might go out. At least to these models, it's not taking place. You see solar takes still quite quite a share, but with all the other actors being in a or working together in a sector coupled system, actually it works. There can be even energy exports. Next slide, please. Talking about costs, in the end, it's all about costs, of course. And here the interesting takeaway is that not the 100% renewables scenario are necessarily the most expensive one, but the message is rather the longer you wait, the more expensive it can get. So in the end, actually, it's a moderate scenario, so 100% by 2050, which is actually 6% cheaper than the laggard scenario. Next slide, please. And but if we not look at investment, but also per unit cost, levelized cost of energy, also we see here that only the 100% renewables scenario obviously are cheaper because you don't have any fuel costs and greenhouse gas costs in 2050 anymore. That brings us to the final slides, and that's of course what we're all aiming for, is getting greenhouse gas emissions close to zero as quickly as possible. That happens with leadership in 2040 and with the moderate in 2050, whereas in the laggard scenario, we still have actually emissions of 800 million tons of CO2 in 30 years. Yeah, and if we look at it on a cumulative level, again here, so for the leadership, of course, because we're already in 2040 at 100% renewables, it's the least amount that will be emitted, while it is more for the moderate and the most obviously for the laggard scenario. Brings us to the summary. Results from this research project clearly indicate that a low ambition pathway in Europe is both a burden for society from climate change perspective and from an economic perspective. So the most attractive pathway is the moderate scenario, modeling zero greenhouse gas emissions by 2050. But however, at least according to our model, it is also possible to reach 100% renewables by 2040 and then also meet the ambitious 1.5 degree Paris target. Yeah, and I think that's it, and that's how we should enter the discussion now. Maybe Christian, let's start, because I think you were responsible for this this modeling part. When you see that, when you look at 100% renewables and you come out with such numbers, it's not the first study of this kind. What's the reservation, the biggest problems you are confronted with when you are talking to people, to incumbents who are, and also to politicians?
Yeah, Michael, many thanks for this question. It's quite interesting. We do the modeling in a transparent way so that the input numbers are transparent, all the assumptions are transparent, the model is described, that one can follow how it works. Obviously, there are opponents that have problems with the outcome, but then I ask the simple question, if there is a problem with the outcome, where is the problem with the model, how it works? It's in a full hourly resolution. Where is the problem with input data, with assumptions? And then the critique is typically very little. So to put it together, there are many who cannot really imagine that such a system could work, but they typically do not find what is the error in the modeling, in the assumption. The conclusion is such a system should rather work. When it comes to, how to say, behind the curtain discussion, then of course we immediately discuss on vested interests. So we have a huge capital stock invested in plants, in infrastructure, which are fully stranded in such a world. This is a huge problem. So how to overcome these investments and of course the players who are involved in such a system. And of course, the clear answer on that is investments in technologies, in infrastructure, which does not support the targets of society. These investments have to be stopped immediately. So that means a ban for all coal investments. When it comes to new gas turbines, it has to be a clear regulation duty that during the lifetime of gas turbines, there has to be a switch to non-fossil fuels, for example. When it comes to other parts of the energy system, it has to be rather clear. For example, selling combustion cars with fossil fuels in 10 years' time will most likely end as a stranded asset, also for the manufacturers, that such products no one needs anymore. And the first clear step to get such a system realized is that the investments in new capacity have to be fully sustainable. And that will be my clear, how to say, recommendation for all crisis packages which are currently put together to stimulate economy. They have to fulfill sustainability targets. Investments in outdated technology has to be blocked to support really the companies and the technology providers which really deliver the technology society needs. Now having investments in outdated, non-sustainable technology is not acceptable anymore, in particular since economies are strongly affected by the crisis. Then we cannot afford to invest in capacity, which is a burden for society. And I think that has to be made very clear right now.
Mark, you're doing your activeness in the same field as Christian, but what's your reaction you get in the US actually regarding your results?
Well, so the reaction has been really good. I mean, over the last 10 years. Also, just to clarify, we developed plans for individual states in the United States, all 50 states, and now we've done 143 countries, including the all countries in Europe. And in the US, the benefits have been so far quite good. There are 15 states now, and well, 13 states plus the District of Columbia and Puerto Rico, which is a territory, that have now committed to either 100% renewable energy or 100% what they call clean energy, which is effectively 100% renewable energy. So in the electric power sector, so there are laws that have, even though the federal government hasn't passed any laws, there are now many state laws, and including this proposal, there've been a lot of proposals at the federal level, including the Green New Deal, but none of them has been voted on.
You're breaking up. Is it only me?
He disappears, no?
Yeah, I think maybe Mark can actually, yeah, Mark, maybe switch off the camera, I think, to
maybe the audio gets better.
Yeah.
I can hear you again now.
Yeah, much better. Yeah, now.
Okay, so yeah, so anyway, we've done very well in terms of getting, because it's not, once we developed these plans, we then engaged nonprofits and communities, nonprofits and policymakers, and there's been a big impact, not only at the state level, but also at the city level. There are now over 150 cities that have committed to 100% renewable electricity, in some cases all energy. But more recently, well, in 2018, we developed plans for 139 countries, and then last year for 143 countries, we updated those. And they're, now getting out to those countries, and so we're hoping that, the information is getting out, and we're hoping that they'll start having a bigger policy impact. So to that end, I'm working with different nonprofits in different countries and policymakers to try to advance the plans in countries, including in Europe. With respect to Europe, yeah, we did do in our 2019 study in One Earth, we had some results for Europe, and it was like a Green New Deal estimate. I think it was about $6.8 trillion to transition all Europe to 100% renewables. And the nice thing was you'd reduce energy consumption by close to 60%, end-use energy consumption, that is, due to the efficiency of electricity over combustion and eliminating energy in the mining, transporting and refining of fossil fuels and uranium, and some end-use energy efficiency improvements. So that would actually result in a lower energy cost, aggregate energy cost, even though the cost per kilowatt hour is similar of all energy, it's still, because you're using 60% less energy, it's about 60% lower energy costs on the annual average. But then there's social costs of reducing like 180,000 air pollution deaths and climate damage. So the social cost benefit was close to 90% compared with fossil fuels for Europe. For the US, there's about a $7.8 trillion upfront cost, which is the Green New Deal cost. So yeah, so these plans really looked at what would it cost each country in terms of its upfront cost and its annual cost to transition, and what was the cost benefit compared with fossil fuels, and in terms of the social cost benefit on top of that. So anyway, I can discuss this more if people have questions.
Okay, sure. Angelina, I think you've been active for a long time also in the utility world, on the utility side. So how is this discussion actually that Christian referred to on stranded assets actually? So because we're still seeing, of course, big investments taking place also in fossil fuels. I think yesterday there was this announcement that Shell is investing, what was it, 4.6 billion and some new gas exploration in Australia. So so that means we're still seeing also money flowing into fossil fuels. But what's the discussion on the utility side in the US? What are you hearing when the discussion comes to 100% renewables?
Right. I straddle two worlds. One is the activist NGO world, which is 100% renewables. Yes, it's possible. Yes, we should do it. Wave the flag, go forward, and have ambitious goals, because, you know, without ambitious goals, we're not going to get anywhere. And then there's the reality of having to function in the utility world and in the grid operator world, and convincing policymakers that this is not only indeed possible, but it's the right way, the lowest cost and the highest value, as Mark pointed out. And it's great to have him supporting this in California statewide, as well as nationally and internationally, to basically showcase that, yes, you can reach 100% with renewable energy, and the electricity sector is easy. That's a no-brainer. We can transition to 100% in the electricity sectors. It's the other sectors that are difficult. So having the California grid operator come along and say, initially reluctantly, as all utilities, that intermittent renewables cannot serve 100% of our load. It's going to be difficult, to visiting Europe and Germany and realizing, yes, this can be done because our fellow grid operators in Germany and in Europe are already doing it by collaborating in regional integration and a variety of technologies, not just focusing on one resource like solar, which would probably be a mistake if we transition to 100% with just solar, and saying we can try and do it in California. We ran the scenarios and certainly started looking at the duck curve, and everybody's familiar with the duck curve, where we have overgeneration in the middle of the day because there's too much solar, and all of a sudden we had to curtail energy and figure out how to work with that. But we saw it more as an opportunity than anything else, because then that allowed us to explore storage and electric vehicle charging, and using the excess energy to potentially make fuels as well, which would be the next step. Stranded assets are always an issue. I mean, we have an ambition here to get rid of all the ones through cooling plants, which are gas plants on the coast of California. We were also forced to close 2,200 megawatts of a nuclear power plant that was in a constrained area that basically started leaking radiation, and it couldn't be brought back online again. And because of renewable storage and some transmission upgrades, we were actually able to meet that demand with less than 200 to 400 megawatts of additional generation that then transitioned to storage as well. So there were tangible examples of being able to operate with more variable renewables if you're able to have the necessary technology to be able to balance the system. And indeed, in California, I'll have to say that we've had several instances of where we've operated on over 90% of renewable energy, that's wind and solar, and we've operated on 100% of carbon-free energy, because we still have some large hydro, which we continue to count as non-renewable if it's over 30 megawatts. And we have one nuclear power plant left, which is going to be phased out in 2024. So having a grid operator like California's grid operator coming forward and saying, yes, you can do it. There are certain precautions that we have to take into account. Reliability, of course, and resiliency is important. And regional integration and being able to balance the market on a wider regional footprint is important. And counting DER and distributed energy resources and being able to island and have a situation of where we can run a renewable resilience system in instances of, for us in California, as we pointed out last year, we had the fires. So a lot of the large scale transmissions were down. How do you operate a grid and how do you make sure that you have the resiliency you need if you're relying on large scale transmission and all of a sudden it's out? So that's an important consideration for us that we have to work through and make sure that we can operate a grid and we have a scenario that allows us to do that, which I think collaborating with others would be important as well. I mean, we value learning from the world. We know that large scale storage is important and Norway is the large scale storage battery for Europe. We want to integrate better with the Pacific Northwest to be able to take advantage of that. On the other hand, we also see a huge value in wind, specifically offshore wind, and the potential of offshore wind to come in and integrate where we have either the ones through cooling plants that are shutting down or the nuclear power stations and be able to feed it into the grid from the ocean into the west. And it coincides extremely well with the solar energy that we have in California as well. So that would give stability to the grid and to availability of variable resources. We also are focused on making sure that we can develop more geothermal with the benefit of geothermal energy development in the Imperial, which is a huge benefit for us. And I think Turkey too has quite a lot of geothermal resources as well, which would be very valuable in such a scenario. It allows us to also bring up lithium. Turns out California is very, very rich in lithium. So there's another symbiotic relationship of where you could have not only geothermal, but a healthy lithium production that can also go into batteries. We realize batteries are short and medium term. Long-term storage is very important for us, and hydrogen would probably be a huge player into that, coupled with then the synthetic fuels. And then going back to the question in a long roundabout way, Michael, stranded assets are an issue. And I looked at the last scenarios, and if I had had more notice, I would have given you the slides. But a lot of our flexible load, especially the peak at the end of the day, is met by gas. And flexible, very efficient gas turbines. And we are building, actually here, even in Huntington Beach, they're building another gas plant that's supposed to be flexible. And it's a result of the major shutdown of ones through cooling plants being synthesized into one or two larger plants. So my idea, and I think it's something that's going to start being much more integrated into the planning, and hopefully we can do this together with collaboration with Europe as well. And Mark Jacobson's group helping to make sure that hydrogen and then synthetic fuels as a basis from the hydrogen become the plan for transitioning all of those potentially stranded assets into the system to 100% renewable energy synthetic fuels. And we think we can do that because as we transition to the 100%, we're going to have a lot more excess energy that should be able to be sunk into the creation of hydrogen through the electrolyzers and then synthesized into synthetic fuels. And we think that that scenario, especially if we can make it more distributed, is going to be the path forward to ensure that we transition not only the electricity sector to 100% renewable energy, but that electricity then is the foundation for fueling the vehicles, which we're going to hopefully have. We're planning to have 7 million of those, and we're on a healthy path forward to more electric vehicles in California. We need to transition though the heavy duty vehicles as well, because just the EVs isn't important. And of course, then the shipping and aviation also. And then there's been a disruption in the market and a customer demand for more renewables. And I can talk about how we've had kind of an organic movement here in terms of the community choice aggregation, which is a bottom-up movement, not just a top-down, which mandates 100% renewables, but a bottom-up community movement to basically say we're taking over the power purchase for our community because we believe we can get to 100% faster and cheaper if we control it and we take that operation away from the incumbent utilities. And they've been very successful because some of the additional benefits that they bring to the community, a buy down of electric vehicles, trading of renewable energy apprentice programs, and having a lot more distributed energy at lower cost throughout those communities. And that has been a huge disruptor in California. And if it continues the way it's been going, over 70% of California's customers are going to be under a CCA framework, which is also exciting and shows where the consumer is and what the consumer demand is. And I'll stop here because I can talk forever about why it's necessary to transition to 100% renewable. Yes, that we can do it. Yes, that the infrastructure can do it, but it has to be focused and planned with a lot of things taken into account. And in the end, all of these studies and all of these scenarios in real life cases that can demonstrate this is the lowest cost, highest value, and in comparison to the status quo of fossil fuel reality, cheapest alternative is extremely useful.
Okay, great. But the issue we're seeing is actually when we look at 100% renewable is simply that the task is a huge one. So if we look at what we did for Europe, is that would translate basically into, if I recall correctly, around 250 gigawatts of solar that would have to be installed every year. We were at around 20 Europe-wise last year.
That's even too low. You know, if you take the global number of 30 terawatts by 2050 or 2040, I think we end up at annual 500 gigawatts to 1 terawatt per year production need. So
yeah, globally, I think in Europe it would be 250. Yeah, so
So for Europe, if we see that we want to have about 7 terawatts in 2030, yeah, we are in the 300 to 500 gigawatt range. Absolutely.
Yeah. Okay. Yeah. Let's say 2040. But nevertheless, the question is, of course, what you see, and I think even in our industry, we see that a lot of people would think, "Wow, how can that be happening?" So maybe coming to Greg, who's active and who's working and living in France, which is has quite some ambitions, but is pretty much lagging behind meeting its targets now for years, and especially also the smaller sector is. Prosumer sector is struggling. So Greg, so how can one tackle that problem, especially if we see the dimensions actually we have in front of us? How can we do that actually from the level where we are now to get where we have to be in order to really meet the Paris targets? Because I think at some point, of course, there will be 100% renewables. That's probably a no-brainer. But in order to really beat time, how can we manage that as if we look at France, for example?
Okay, this is the purpose of what I prepare on my slide, so I can show you this, and I'm going to answer to this question because in France it's a very specific situation because we have got a lot of nuclear, and the nuclear is a low carbon energy, so it's very difficult for renewable to emerge. And I'm going to show you very few slides to show you what is the main roadblock I know, and if you are able to solve these two roadblocks, we are going to make a 100% renewable. Okay. Can I share my
Thomas? Can you share? Thomas?
Yes. Who is speaking now? Sorry, because I was taking.
To Greg, please.
Okay, second. Yes. Okay.
Okay.
Yes.
Okay.
You have the green green bottom of the.
I don't know. I don't like.
Yeah, you click on the green little button which has share, and then you can.
I can.
First, you have to go down to create this commands row. You know, you have to go down with your pointer to the bottom of the picture.
Okay.
And then you get the symbol share screen.
Yes, yes.
Green, of course.
Of course.
Okay, okay. It asked for me to give authorization to.
I had the same problem, so you might want to send it actually to Thomas, because then you will have to quit the system.
Ah. Okay, I authorize Zoom.
Yeah.
Yes. Sorry. It's okay.
Oh, fantastic! You did it.
But this is not the good one. Do you see my screen or not?
Yeah, perfect.
You see come what?
Yeah.
We
Okay.
see you. Yeah.
Okay. You see it now?
Yes.
Yes.
Okay. Sorry. Okay. Renewable energy now are cleanest, the most resilient, and the most democratic. They become today. We can see with the different people. It's become now cheapest. We can see different world record of energy is very, very cheap. So what is the main roadblock today? Today we are energy. It's an organization about like a machine, and we see it's very difficult for energy system because it's like Charlie Chaplin. We need to. It's very difficult. We are the slave of the energy because we can have a negative price. For example, today in Europe, we have got a negative price. Today we have a minus 80 euro by megawatt hour. It's a nightmare for energy because everybody is losing money. So we have got a lot of energy in the system, but not. We are a slave of the energy. We can't manage the load. So the purpose of ComWatt is to find a way to find a solution, and we see two solutions. First, we already discussed about that, it's storage. And second point, it's to change the regulation. About regulation, the point of view of ComWatt, we need to move from a mechanical organization to a system like an organism, like something is alive. And we think that the net billing is the future of the energy because every building, every people who can produce energy and consume can share energy, and we can have the market to have got a price. The price can change during the day from if the grid need a lot of energy, the grid is ready to buy a lot of energy, so increase the price. And if the grid don't need any energy, it down the price, and nobody want to sell to the grid because it's not attractive. So we think we are going to move to something like an organism. We're going to balance in the real time everything, and at the end we can solve the issue of storage with less battery and a less system of storage that that we need if you doesn't make this kind of regulation. So this is, we can see it in this slide too. We come from a mechanism with centralized production owned by very few big monopoly. Production is far from consumption, and everybody is in a silo. And in the next future, I don't know, it's the next year or in 10 years or in 20 years, I don't know, we can see new systems like Angelina explained with the community of energy, and we can have resilient self-production. We can have different people. We can be able to own the system of production of energy. It's a citizen. We can own this system. So I think it's a good direction to help people to take this opportunity. And the last one, it's to show what is the ComWatt technology. ComWatt technology, it's a technology of connected objects. We can monitoring the production and the consumption, And in France, this is a very specific situation because we have got a lot of nuclear. 80% of the French energy come from nuclear. So the nuclear ask we have got electric boiler for warm water. We have got electric heater for everything. So everything is electric in France. So it's a very, very good things to help to introduce renewable energy, because when we have electric heater, electric boiler, appliance, electric car, and heat pump, we can have a storage in thermal storage around 90 gigawatts. So it's a huge quantity of energy we can move every day, and we can go to the 100% of renewable in France, because we have got everything to store. We need battery, of course, but less battery, because we have got a huge system of energy storage in energy storage of heating system. Okay, this is my answer. I hope it's clear.
Okay, maybe Greg, a follow-up question on that. So that model looks good. So what's the reason we have in France less than 10 gigawatt of solar installed today, and France is now basically every year missing its targets the government is actually trying to achieve? So
yes.
If we want to go really big to 250 gigawatts solar a year in Europe, so that means there would be dozens of gigawatts that would have to be installed in France as well. So how can we get there?
It's very simple to understand. In France, we have got EDF. EDF, it's a very huge company. It's a monopoly of production of energy. And EDF have got a very high fixed cost. If a nuclear plant produces energy or don't produce energy, the cost of the nuclear plant is the same. So every time that people want to reduce the consumption or people produce the energy, it's the energy that people economize or produce from themselves. It's the energy that EDF or the nuclear plant can't sell. So if you have got a company, we sell the less and less energy and have the same cost, we have got a problem. And today EDF have got a huge need a lot of money to survive. So the government make an injection of a lot of money in EDF every year, but each time we have got a transition of energy, EDF lose a lot of money. So it's not a good business for EDF. It's not the responsibility of EDF. It's the responsibility of the French government. We put EDF in a very complex situation, and the solution to go out of this issue is to separate EDF, the main utility French, in two parts. The green one, we can renewable energy management, and the blue one of EDF, which is going to manage everything about nuclear. So it's the only issue to go out of this low renewable energy share in France.
Okay. Gregory, quick question about the nuclear power plants. They're uneconomic here as well, and also they're not flexible. So as you introduce more renewables and you have more need for flexible generation, nuclear power plants are not able to follow that flexibility demand. And also they need to be relicensed. I assume that's the same in France as well. What's the situation with relicensing? I mean, nobody in the world in their right mind will be building a new nuclear power plant, but the relicensing can be an issue. So what's the situation there?
The situation about the development of the nuclear in France and in Europe?
The relicensing of existing plants. So when the license runs out, the life, what is the plan for that? Is there a plan? Like, for instance, the last nuclear power station in California, Diablo Nuclear Power Station, will be decommissioned in 2023 or 24 because that's when the license expires and it's not going to be renewed.
Today we just closed last month one nuclear plant. It's the first one in the history of France we can close. It's
wow.
In the east of France, and the target of the French is to go to today we have 70% of energy from nuclear in France, and the target of the France is to go to 50% in 2035. So this is the target, but the cost today, it's 1 billion euro for one nuclear plant to go 10 years later to be able to produce energy during 10 years. So the cost, the levelized cost of energy of nuclear in France is around 7 cents by kilowatt-hour around.
So is it the policy of France not to renew licenses, because in the most cases renewal of license means a big overhaul to come to the safety standards which we have today compared to 30 years ago?
Yes.
Christian,
yes.
maybe you also want to take that, because I think you looked at also the nuclear, the development of nuclear in Europe for the different countries.
Yeah, maybe let's answer me briefly on that. We have to separate existing running nuclear plants and new nuclear plants. For new nuclear plants, it's absolutely clear this is outstanding waste of money.
Yeah.
Because a new nuclear plant costs around about 100 euros per megawatt hour, and this is already subsidized. The real cost will be still higher due to subsidies for risk and liability insurance and others. While you get today for 30 to 40 euros per megawatt hour in many parts in the world, solar and wind. So this is outstanding waste of money, and such statements you get nowadays even from CEOs of utilities which still run nuclear. So that's absolutely clear. And the only, how to say, rational, I would not say it's justifiable, but the only rational what we have is, for example, for the case in the UK, where Hinkley Point C is built for a new nuclear power plant, but the clear intention is to maintain the nuclear infrastructure in the country for military purpose. So, of course, the same will be true in France and in China, in US, in Russia, in other countries. Simply to maintain the infrastructure, and it seems to be easier to sell these investments. For the case of UK, we talk on 30 billion euros to sell this investment to the public in form of we need this energy instead of more military budget is needed. So this is simply the truth, and we have to talk on that. Now let's come to the existing plants. The existing plants, we have to, how to say, accept that the electricity which is generated in these plants is on a low level of greenhouse gas emissions. However, for the price, if in such a plant something goes wrong, in a radius of 1,000, 2,000 kilometers around, huge stock of value is typically destroyed. Whether it happens by a technical failure, whether it happens by a technical failure was in Chernobyl, whether it happens as a consequence of a technical failure of a natural disaster, as in Fukushima, or it can be a terrorism attack.
Yes.
So there are different reasons why existing plants can produce huge problems with a nuclear meltdown, and this is typically not covered by liability insurance. No one could afford that. This is covered by risk-taking of all people living in the area, and then society has to decide whether this, how to say, long tail risk, we call it a black swan. With corona pandemic, we got such a black swan. Of course, with nuclear, this exists, and the older such plant gets, the higher is the probability that it will happen, and this risk has to be balanced with when to shut down the plants. So the technical design of all these nuclear plants is 40 years. Sometimes they're prolonged, the technical lifetime, with additional regulation to 50 to 60 years. Typically, it costs 1 to 2 billion euros for 10, 20 years of lifetime extension. And we now even see the situation that new investments in new renewable is even lower in cost than only the lifetime extension of existing nuclear. And this we saw documented in the market in the US, and we have such studies also for France. So this, of course, brings on the table when to really stop nuclear if new investments do not really make sense. but even the lifetime extension of existing ones has still the risk that we have a major risk of nuclear meltdown and all the disastrous consequences, while for the money we have to invest in the lifetime extension, we could build a 100% renewable alternative. So money has to be taken in any case. So from that point of view, the societal business case from my point of view is very clear. A fast renewable ramp up. For the case of France, it will be solar and wind, of course, and not waste the money for a still continued risk. And even a nuclear plant that then runs 50, 60 years, of course, has a much higher risk than a new one. So from that point of view, from a societal choice, even lifetime extension seems to be not attractive and beneficial.
Right.
I totally agree with that as well, and wanted to also point out that as with all fossil scenarios, including nuclear, let's not also forget, yes, it may be low impact on climate, but it also uses precious freshwater resources for the cooling, and that is a problem we're going to be facing again with climate change and the scarcity of water which is becoming an issue. So that needs to be kept in mind. The largest freshwater usage outside of agriculture worldwide is the fossil industry. So as water becomes more precious, we need to start factoring that in, along with the societal risks of a meltdown, along with the pollution and the healthcare costs as a result of fossil energy use. Those externalities need to be factored in every single time.
How can we
maybe just to add on that, because we published end of last year a study on that, the water consumption of thermal power plants in a 100% renewable energy system can be reduced by 98% globally. We did that for all power plants globally with 50 megawatts of capacity and higher in a full resolution for all river systems. So this is enormous, how to say, release what we could have with water availability to be used for what we really need for food production, or even that rivers have the chance to still reach the ocean, because we have rivers nowadays which do not even anymore reach the ocean. And of course, what we know from the thermal plants, whether it's coal or whether it's nuclear, and of course, again, France, Germany is an example for that, when we have really hot summers and we have more of them, then these plants have to be shut down anyway, because the rivers simply have no water anymore for cooling.
Right.
Yes, it's true. In France, 50% of the drinking water is used by nuclear plants in France. 50%, half. It's huge.
We really need to talk about that aspect more. I know we talk about the other issues and the clean air and everything else, but the water resources and the use of water resources as a result of the fossil industry, and particularly the nuclear industry, is a very important point.
And actually, we should emphasize that our approach gives a much more stable, resilient, reliable energy system than the energy systems of the past, because we are really installing a grid which reacts extremely flexible and automatic to all disturbances, whereas when a huge nuclear or thermal power plant goes down, this creates a huge problem for the grid and so on. And of course, if a hot summer doesn't allow to have the cooling water, then states like France come really into big trouble, and these scenarios might increase in the future, unfortunately.
Right. I mean, you're completely right, Eike, because we saw that in real life with the San Onofre nuclear power station, 2,200 megawatts in a constrained area, which was supposed to be our backbone, our most reliable resource, right? Everybody said nothing could possibly go wrong. And when it did, we had to scramble and go into unprecedented collaborative modes with the California Energy Commission, with the Public Utilities Commission, to figure out how we are going to be able to meet that demand in a constrained area in terms of transmission. And it was actually widely accepted that solar and storage saved the day in a major way, because they came on very fast and it was very flexible. And then that gave us the ability and the confidence to move forward with larger and larger percentages of renewables as a mandate.
I always say, if Fukushima would have had 100 kilowatts of PV on the roof of the reactor, then the meltdown would not have happened, you know.
Let's maybe talk a little bit also on natural gas, especially here in Europe. There's a lot of politicians who really bet on gas for various reasons. One is because they don't, and also some think tanks, especially when considering it as a bridge solution, how they call it, simply because they don't believe that the massive volumes of renewables that is needed in the short run can be built. So how can we deal with that? So how can we make sure actually that that renewables are getting the push that is needed in order to circumvent that bridge, or keep it as short as possible, and that not new actually investments are being taken. So that goes to everyone. So I think that concerns also everyone.
Well, I can talk about it from a very practical point of view for us specifically, which is we need that flexibility and we need that ramping, very fast ramping of about 15,000 megawatts for 4 hours every evening. And the majority of that is currently being met with gas. So our gas plants, and the most efficient ones that we're investing in, are used sporadically. They're used to balance the load at the end of the day and sometimes early in the day to meet that peak demand. And then they basically stay idle most of the day as well. So fossil energy, initially we saw it with coal, we're seeing it with gas, is being shut down or divested because it's simply not economic. So as a society, if we needed for the short term for that flexible demand, which we do until we have more storage and more flexibility, and we point that out, is going to be something that is needed. And then as we ramp up storage and as we ramp up longer term storage, and as we get better at instead of energy following demand, demand actually following energy, from the customer point of view, we're going to even diminish the use of those gas plants even further. And then of course, long term, there's always the option of transitioning them to hydrogen or synthetic fuel. And hopefully we'll all get collectively better at that, helped by the availability of more and abundant and excess amounts of cheap renewable energy.
But there's obviously also now the discussion, and I think this topic is really a buzzword. It is hydrogen, and of course the gas industry also smells that opportunity. That we are not talking about renewable hydrogen. Okay, they are clever enough to call it not go just the blue way, but there's always the digging carbon solution or opportunity. So how can we make sure actually that we as the renewables industry are capturing that pathway completely?
Maybe I could add a few things from the perspective of Turkey, or what's happening in Turkey on the gas renewables nexus. Turkey has literally no resource available in terms of natural gas, so it's a fully import-reliant economy in terms of gas. So another issue which Turkey suffers in terms of increasing system flexibility, the interconnector capacity is rather limited. So there's very little cross-border trade, which implies that Turkey needs to resolve its flexibility on its own in terms of its technology development, especially if it no longer wants to rely on gas. And I try to present that upfront the technology options. Obviously, storage is one, and we have no pump hydro, and we're looking into that as well in Turkey. However, what Turkey needs to make most progress, and I think a few presentations have slightly addressed that, and it's beyond technology, it's on the market design. What we need to, I mean, from an emerging economy perspective, especially focus on is to go hand in hand with technology development on wholesale market design for increasing system flexibility, and also business models that can empower consumers, which we have as a starting point a monthly net metering scheme. So that's good to create the first distributed energy market, but to be able to make it more cost effective, to be able to make it more consumer driven, there needs to be business models which links the DSOs, utilities with the end users. So these parts, non-technology, so systemic innovation, one could even identify, there needs to be much progress made. At the end of the day, then you can rely much less on gas as a import-relying economy like Turkey when it comes to the question of flexibility.
Okay. Anyone else? Okay, I think we're coming. Yeah,
just
please.
one important issue which came up in the discussion now is really what can we do to get the production volume quickly enough up, and I talk about mainly PV production, to what we need. If I just take the numbers which come from Christian Breyer, that we need globally 30 to 50 to 70 terawatt of PV, let's say 30 terawatt by 2040. That means by 2040, we have to generate 30 terawatt in 20 years. And this means about 1.5 terawatt per year on the average. And because we don't have 1.5 terawatt per year, we have to look even at 2 terawatt per year production volumes. At the moment, we are incredibly far away. So maybe we have to switch gears. We have to go to governments and say, if you want to have any chance to follow the path as Christians and the study from which you mentioned, Michael, has shown, to fulfill what actually is the lowest cost future scenario, we have to take action to really come from 150 gigawatt per year to 500 gigawatt per year to 1,000 gigawatt per year faster than if we just leave it to the market. I mean, you know, if the defense people would need fighter planes, they don't wait till the industry builds enough fighter planes. They will simply contract the fighter planes and they will be built and they will be paid. And I think the importance of getting to the 1,000 gigawatt per year annual global PV production is at least as important as the fighter plane issue, you know? So I think maybe coming out of our meeting today, we all need to scratch our heads and see how in the world can we quickly ramp up production capacity at, of course, the best technology level, of course, at the lowest possible price, to reach the goals which we have now so clearly defined. I think that is something I did not have in my perspective, but maybe we can all take away from our session today.
Yeah, maybe we can, so because I think we're coming to an end. I think that's great, Eike, that you mentioned this huge challenge, because I think that what I would like to hear maybe from each of you, what do you think? Because I think the next 10 years are really crucial. So this should be actually already the solar decade. So or the solar and wind decade. So I think what do we have to actually do in these 10 years now to prepare that by 2040 or 2050, we really can reach 100% renewables. So what we did at Solar Power Europe, when we did that study, we also thought about policy recommendations, and we just thought for Europe, we need 3 things. Basically, first, we need to have actually a clean energy package body. So really an institution that looks specifically at that issues and takes care that all these barriers that we have with permitting, with grid capacity, all these needs, that this is being tackled actually in a focused way. And the other 2 things is we have to look at actually also large-scale solar involving citizens, which is really important, because when we look at all these amounts that Eike just mentioned, we will have a lot of solar systems. And some people might not like it. So you will have NIMBY effects, obviously, also. We already have that sometimes now. Wind is suffering quite a bit under this these days. We will also see that in solar. So we have to take actually the citizens with us to make that happen. And the third one is actually that we were looking for simply a pan-European solar rooftop program that simply California is pioneering that. That's simply not only every new build has to have solar on its roof, but basically by 2050, every house has to have solar on its roof. So that would be our 3 recommendations. But maybe everyone can simply briefly say what he, she thinks should be done and recommend it to policymakers. Maybe Digger, I see you on my screen first. You start.
Sure. I think what I conclude from this discussion is the social and economic benefits of energy transition of solar PV and wind and all these flexibility that can be brought to the economy needs to be understood better in terms of industrial economy, for social dynamics, in terms of job creation, and in terms of the broader macroeconomic benefits, and especially made part of a core part of the economy stimulus recovery plans after the period we're experiencing. And if we can understand and if we can make the foundation of our development plans based on this understanding of the benefits the transition brings, I think that would be my take to transfer to the local policymakers here.
Mark?
Just my point of view, the one point is the community of energy. I guess the community of energy is okay to give the power to the people, to the citizen. And if we let the regulation go in this direction, I think people is going to take the transition with them. And we can help the collective self-consumption, because today in France is the regulation is very complex, it's very difficult to go ahead, because the old actors of energy don't want that the people produce their own energy. They don't want that people organize themselves. And so I think if we help people about these 2 points, we can go to 100% of energy in France very quickly.
Okay, Mark?
Well, I think the key has been in the US, for example, taking these energy plans, which are kind of science-based plans, and giving information to nonprofits and policymakers. People in the nonprofits often are at the front lines in terms of trying to affect policy. And so just to give you an example, like in North Carolina, there are a couple people working in nonprofits who have taken our energy plans and gone to 14 different cities, including the capital, and have obtained commitments from these different towns and cities to go to 100% renewable energy. And when you do this, and then like groups like the Sierra Club, which is a big nonprofit, they've gone to hundreds of cities and on the ground gotten commitments. And so then when you get this large flow of people and people who have more information available at their fingertips, then it's easier to get than governors. And so lots of governors have supported this as well, due to the fact that a lot of people in the parties, in the individual parties, like the Democratic Party in particular, are supporting 100% renewables. And so when you kind of, it just seems like there's a movement that flows from the science, but also the people want to see a change. So it's important to kind of combine, it's to work with different groups. It's not only scientists have to work with business people and nonprofit people and nonprofits and policymakers, and also cultural leaders, to really engage everybody. So it can't just be a few people. It has to be a broad coalition moving into to affect government policy. So I think, yeah, that's really the way I see it has worked in the past, and hopefully that's probably how it'll go in the future.
Okay, Angelina?
Yes, and building on what Mark has said, you do need a broad coalition, and we have to keep in mind that having shining examples such as leading utilities or grid operators that actually support the ideas and can showcase that this can happen in real time and in real life is important. Having a cross-sectoral collaboration is extremely important in breaking down the silos as well, in terms of transportation, in terms of buildings. Like California now has an initiative of all new construction starting in 2020, starting with residential, then commercial and industrial by 2025 and 2030 respectively, should incorporate solar. We couldn't push it as far as zero net energy, but still that's important. Having 7 million electric vehicles on the road. And then from a grid operator perspective, making sure that when you have the market, you have your market programs, you have your market design, you expand the footprint, you bring in resiliency and reliability, factor in for the unexpected. What always keeps me up at night is like, what's the unforeseeable? What couldn't we foresee? We couldn't foresee San Onofre. We couldn't foresee the fires necessarily and the devastation. and the fact that people stayed without power for a while. So how do we build the energy system of the future to be 100% renewable and take all of that into account to the extent that we can? And relying only on one resource is not the right way to go. Overly relying on solar, which is great, fantastic, and low cost, is probably not going to get us to the 100% as efficiently as also incorporating wind, particularly the benefits of offshore wind, incorporating hydro, incorporating geothermal, incorporating DER as well. And then building on the customers. The customers, bottom up, are the change agents. They want to see a much more green system and a much more distributed system that in the future is going to be diversified, decentralized, decarbonized, and democratized, literally power to the people, because customers now can control the energy that comes to their homes. They can control the power that drives their car, and they have a much louder voice in a realization of what impact the energy system can have on their environment, well-being, and health. And I think taking the coronavirus into account and amplifying the message that climate change is possibly a huge driver for this virus and maybe others to come, that we should also keep that into account as we try to come out of this crisis and build it not with a fossil infrastructure, but rely on renewable energy and the Green New Deal as what's functionally going to bring us and support us in the future and ensure public health as well.
Great, thanks. Christian.
Yeah, there is not much to be added anymore, but I guess what is really important to make clear what society accepts as new investments. Because once the new investments are managed in a sustainable way, we have in 15, 20, 25 years later, automatically a sustainable system in total. So organizing the new investments is the most critical point. That comes to power plants, but it comes to vehicles. But for example, it comes to fuel usage. There are the first discussions now in Europe. Airlines have to be supported due to coronavirus, but if the public spends hundreds of millions, maybe billions of public money to such strongly affected companies, why not linking that to environmental targets? And the target could be linked to the money. Okay, a specific share of the fuel has to be non-fossil fuel in the second step by regulation. And of course, we need an effective greenhouse gas emission price. And this can be organized by countries on their own. If emission trading scheme is not working, one can introduce a tax. Countries are doing that work. We see more and more countries, for example, in the northern hemisphere, where we have a heating period in the winter half year, that there are increasingly efficient heat pumps used, and heating systems burning fuels are simply banned. And the reason is there is a carbon tax. So this is a very simple measure to get a system more clean and more effective. And of course, this electricity in those countries is based on renewables mainly. So there are many, many different measures, and in different sectors we need different measures. For example, let's take the car industry. A very simple measure is that the major cities in the country, in the region, simply do not allow from a specific point onwards having combustion cars in their cities. Then it's extremely unattractive to have a combustion car. And the solution will be most likely a battery electric vehicle. If we then go to battery electric vehicles, then we can fix the quality of electricity, so a CO2-free electricity. Still, we have embedded emissions in the car. Again, this can be fixed with a regulation, for example, with emission-free steel. We can produce steel based on hydrogen, and then all emissions in the steel, which are today to the coal, which is used for the iron reduction, can be fully phased out. This can be done by a simple regulation, and the price of a car is not going up much due to that. The same can be done with the building environment, where a lot of steel is used in conjunction with concrete, but all the steel could be, for example, emission-free. So this is something societies can decide on, and then it can be executed. The price of a house is not increased much due to emission-free steel, which is used. Typically, the price of a building is very expensive to the very low cost real estate you have to buy from the ground itself, but not from the building. So there are so many measures where we can push the system into a clean solution, but of course willingness is required. So I hope, at least in democratic countries for next elections, that we will not forget Fridays for Future, and we have the young generation again on the street when it's allowed again to be on the street, to really enforce with pressure the change. Because unfortunately, our, how to say, postmodern democratic systems only react on massive pressure. So the consequence is we need massive pressure, and luckily the young generation has fully understood this absolute necessary requirement.
Okay, thanks, Christian. Nice final words. So for me as a moderator, that leaves me only to say thanks to everyone. That was a great panel. Thanks so much to Thomas for facilitating that. Thanks a lot for Eike for organizing that, and thanks to everyone for participating. Have a nice day, evening, wherever you are, and keep in touch. All the best.
Maybe the last word is like the last session of today. So I would like to thank you so much to our participants from California to being so early, for the participants from Europe to being so late. And I think that it was very interesting panel discussion. So I think that we can ensure with Professor Weber that it's not the last panel, yes, and you will receive our invitation very soon, because I think that this is so important topic that it should be carried on until the moment when we reach the Sustainable Plus World 100.
Yeah,
and together we are stronger.
It's so beautiful that we experience now around us how this world can look like. I think this is a great experience which we get now from the clean air, from the clean sky. It's fantastic.
Thank you so much.